So hello friends, myself Piyush Lokhande and today I am solving set D of first internal test paper of computer oriented numerical method. So welcome. So friends, our first question is find the cube root of 5 using Newton-Raphson method. Correct up to 4 decimal places. So this is the solution. We have x equals to cube root of 5. So first we will cube on the both the side of this equation. We get x cube equals to 5. Now we have to convert this equation in form of function f of x. So on converting into function, we get f of x equals to x cube minus 5. Now we have to find a root for this function. So we will put different values of x. For example, x equals to 0, 1, 2, 3, etc. So on putting x equals to 0 in this function, we get f of 0 equals to minus 5. Then we will put x equals to 1 in this function, we get f of 1 equals to minus 4. Then we will put x equals to 2 in this function, we get f of 2 equals to 3. And we will stop when we will get a first value as negative and second one as positive. So we will consider that our root lies between 1 and 2. Now we will find first differential of this function, which is f dash x equals to 3x square. Now we will consider initial x0 equals to 2, because on putting x0 equals to 2 in function, we get a positive 3 value, which is nearest to 0. So now by the Newton-Raphson formula, which is xn plus 1 equals to xn minus f of xn divided by f dash xn. For first iteration, we will put n equals to 0 in this formula, and we will get x0 plus 1 equals to x0 minus f of x0 divided by f dash x0. Now we will put values of x0, f of x0 and f dash x0. So on putting values, we get 2 minus 3 divided by 12, and value of x1 equals to 1.75. For second iteration, we will put n equals to 1. Then we will put this n equals to 1 in this formula, and we get x2 equals to x1 minus f of x1 divided by f dash x1. On putting the values of x1, f of x1, f dash x1, we get x2 equals to 1.75 minus 0.3593 divided by 9.1875, which is the on solving we get x2 equals to 1.710, which is the value of x2. Now for third iteration, we have created a table which contain first column of iteration, second of x0, third for f of x0, and fourth column for f dash x0, and fifth column for x1. So in third iteration, we will put n equals to 2 in this formula. So we get x0, x0 1.7108, and f of x0 we get 7.9728, and f dash x0 8.7813. These values are putted in this formula, and we get our new x1 equals to 1.709976. Now for fourth iteration, we get x0 equals to 1.7099, f of x0 4.2302, and f dash x0 8.7720. On solving, we get 1.7099, which is which is our precise answer for this. So cube root of 5 is 1.7099. Now our next question is find the so our next question is write an algorithm program for finding square root of 5 using fixed point iteration method. So this is the algorithm for fixed point iteration method. So first step is start. Then in second step we will define a function f of x. Then in third step we will define function g of x, which is obtained from f of x equals to 0, such that x equals to g of x and g dash x is less than 1. Now in fourth step, we will choose initial guess x0, error e and maximum iteration n from the user. Then in fifth step, we will initialize iteration counter step equals to step plus 1. Then in sixth step, we will calculate x1 equals to g of x0. Then in seventh step, we will increment iteration counter step equals to step plus 1. Then in eighth step, we will check a condition. If step is greater than n, then we will print that it is not convergent and we will move to step number 12. Else, we will move to step number 10. Then in step number 9, we will initialize x0 equals to x1 for the next iteration. Then in 10th step, we will check condition. If function f of x is greater than e, where e is error, then if it is true, then we will move to step number 6 again, and if it is false, then we will move to step number 11. Now step number 11 is display x1 as a root, and the 12th and the last step is stop. Now our next question is find the output of Gauss-Seidel algorithm for given matrix. So we have given a matrix which is this, which has four rows R1, R2, R3, R4, and five columns C1, C2, C3, C4, and C5. So first we will convert this matrix into form of equations. So first equation is 10x1 minus 7x2 plus 3x3 plus 5x4 equals to 6, which is this. Now for this, 6x minus 6x1 plus 8x2 minus x3 minus 4x4 equals to 5. Then for this, we have 3x1 plus x2 plus 4x3 plus 11x4 equals to 2. Then fourth row, we have 5x1 minus 9x2 minus 2x3 plus 4x4 equals to 7. Now we have to convert uh, into diagonal values for this diagonal elements. For example, x1, x2, x3, x4 values. So we get x1 equals to 1 by 10 under bracket 6 plus 7x2 minus 3x3 minus 5x4, which is equation number 1. Then for x2 we get 1 by 8 under bracket 5 plus 6x1 plus x3 plus 4x4, which is equation number 2. Then for x3 we will find 1 by 4 under bracket 2 minus 3x1 minus x2 minus 11x4, and we will name this equation number 3. Then for x4 we get 1 by 4 under bracket 7 minus 5x1 plus 9x2 plus 2x3, which is equation number 4. Now for first iteration, we will put x2 equals to 0, x3 equals to 0 and x4 equals to 0 for finding x1. So when we put these values, we get x1 equals to 0.6. Now for finding x2, we will put x1 equals to 0.6, which is our latest value for x1, and x3 is 0 and x4 is also 0. So on putting in equation 2, we get x2 equals to 1.075. Now we get new values of x1 and x2, and x4 equals to 0. So we will put new value of x1, x2 and old value of x4, which is 0. So we get value of x3. So on putting x1 equals to 0.6, 1.075 as x2 and x4 equals to 0, we get x3 equals to minus 0.21875. Now we will put x1 equals to 0.6, x2 equals to 1.075, x3 equals to minus 0.2187 in equation number 4 to find value of x4. So on putting in the equation, we get x4 equals to 3.3093. Now for second iteration, we have created a table which consists of 5 columns. First one is iteration, second one is x1, this is x1, and here x2, x3 and x4. So in first step we get x1 value 0.6 and x2 value 1.075, x3 value we get minus 0.2187 and x4 value 3.3093. In second step on calculating, we get x1 value minus 0.2365, x2 value 2.0749 and x3 value minus 8.9420 and x4 2.2432. For third iteration, we get x1 equals to 3.6134, x2 equals to 3.3389, x3 equals to minus 9.2137, and x4 equals to 0.3895. And in fourth iteration, we get 5.6319 as the value of x1, 3.7666 value of x2, and minus 5.0477 value of x3, and 0.6613 value of x4, and so on. We can calculate uh, more values for greater precision. Uh, Further iteration might be needed if we need it only. So thank you. Please like, share, and subscribe to our channel. I hope you like this video. Thank you.